Hello friends, today we are going to discuss about this English alphabet I. Now all of us who have gone through the chapter complex numbers know what this I is. Yes, this is the imaginary number I. So in this short video we shall discuss the basics of I, that is how did this I pop up, and one of the most widely used misconception about I. Now if we have to start the discussion about the origin of I, we have to bring up another topic of mathematics, that are quadratic equations. Now we all know quadratic equations are those class of equations which gives two solutions. For example, if we have this equation x square minus 1 equal to 0, we can easily tell that this equation has two solutions, and those two solutions are plus 1 and minus 1. Now the question is, why did we tell that these are the two solutions? It's very obvious, because you see, if we replace 1 in place of x, what happens? 1 square minus 1, that is equal to 0. Similarly, minus 1 also, if we put in place of x, minus 1 whole square, that is plus 1, minus 1 equal to 0. In other words, the numbers which when replaced in place of x satisfies the equation, we call those numbers to be solutions of the quadratic equation. Now what happens if we just put a plus over here? This remains a quadratic equation, but what about the solution? Like the other equation had solutions plus 1 and minus 1, can you find a solution of this equation? Till that day, mathematicians knew the concept of real numbers only. So mathematicians did not find any real number that if you put in place of x and you square the real number and you add 1 to it, you get 0. Because if you add something to a positive number, you square any number, negative or positive, it will be non-negative. Now a non-negative number plus 1, how can it be equal to 0? Here comes that there exists no real number which satisfies this equation. Mark my words, there exists no real number that satisfies this equation. Now if there are no real numbers which satisfy this equation, mathematicians thought there might exist a different class of numbers which are not real. Now what are not real? Those are called imaginary. Here comes imaginary number concept. Now mathematicians thought there might be some imaginary numbers which will satisfy this equation. Now imaginary starts with I, hence I became the solution of this equation. Now see, if I is the solution of this equation, what happens? You can replace I in place of x. What happens if we replace I in place of x in this equation? See, so you can tell I square plus 1 equal to 0. In other words, or you can tell I square equal to minus 1. So this is the origin of the imaginary number I. You can define I to be such a number that if you square the number, you get minus 1. But unfortunately, apart from this definition, we see that in textbooks there exists another definition of I. What is that? In some of the textbooks we see they define I to be such a number that you can tell I equal to square root of minus 1. Initially, this definition seems very obvious, because if you tell I square equal to minus 1, by the definitions of elementary mathematics, you remove the square, on the other side of equal to, you get a square root. So I equal to square root of minus 1. But my friends, this deduction is not that simple. Let us see why. Because if you assume this deduction, this will lead to a very, very serious error, and that error will be a threat to the very definition of I. Let us see how. See, if we consider this definition to be true, it will obey all the laws of elementary mathematics. Now, one of the important concepts of elementary mathematics is that suppose there are square root of two real numbers multiplied with each other. What can you tell this to be equal to square root of AB? So square root of A into square root of B equal to, that is equal to square root of AB, provided A and B are real numbers. So if we go by this definition, let us see what happens. I square. You can tell I square equal to I into I. Now if this is the definition, I equal to root over minus 1, which means you can replace I with root over minus 1. That means whenever you can see I, you can replace I with this. So I have seen I like that. So I can replace I with root over minus 1 into root over minus 1. Now minus 1 is itself a real number. Minus 1 is itself a real number. That means it will follow this definition. So we can write this one as minus 1 into minus 1, which is equal to this, which is equal to plus minus 1. Here comes the error. See, by definition, I square gives the value minus 1 only, but we see that here, if we go by this definition, I square gives two values, plus 1 and minus 1, which is erroneous, which is wrong. Why did this wrong result come? Because we assumed, we replaced I with square root of minus 1, which is not true. So from the next time onwards, if you see anything like this in the textbook, do remember that this definition is not correct. You cannot tell I equal to root over minus 1. Instead, the true definition of I is such a number which if you square gives minus 1. If you have liked this video, please do share with your friends and subscribe to my channel SB Ganit.